Hello everyone, welcome to Oakscam Academy. My name is Ogeneti Mamogo. Now if you are new to my channel, feel free to hit the subscription button below. Also like, share, and of course avail yourself to the lesson so as not to be left behind. Welcome back. So in our last class, we talked about chemical combination. We discussed what a compound was. We said that the compound is a combination of two or more elements chemically joined together or chemically bonded together. We also discussed the types of bonds that exist. We talked about covalent bonding. We also talked about ionic or electrovalent bonding. So as a quick recap, please, if you are yet to watch that video, do well to check it on my channel. It is titled Chemical Combinations Bonding. Okay, but as a quick recap, we're going to be revisiting covalent ionic bonding. So for ionic bonding, we said ionic bonding is a type of bonding in which there is complete transfer of electrons between elements. Okay, so there is complete transfer of electrons. While for your covalent bonding, in covalent bonding, there is sharing of electrons. So for electrovalent, there is complete transfer. So like for example, the one that exists between sodium and chlorine. So when sodium reacts with chlorine, sodium has to give away one electron to chlorine to attain stability. Okay, so that's an example of what ionic or electrovalent bonding. Now for your covalent bonding, there is what sharing of electrons. Okay, so the element has to share electrons in order to attain stability, like in the case of NH 4, or rather CH4. So like in the case of what? CH4, which is methane. So please take note, electrovalent, complete transfer, covalent, sharing of electrons. So we're not able to conclude that lesson. So today is going to be a conclusion of that topic. So we're going to title this Chemical Combination Bonding Part 2. So we're going to be discussing coordinate covalent bonding, metallic bonding, and hydrogen bonding. First things first, we're going to be talking about coordinate covalent bonding. So what is coordinate covalent bonding? Coordinate covalent bonding is a type of bonding where there is sharing of electrons. Now you can almost tell that it's extremely similar to what covalent bonding. But the difference between covalent bonding and coordinate covalent bonding is that in coordinate covalent bonding, only one atom is contributing the electron. Only one atom is sharing the electron. Unlike in covalent bonding, where there is sharing between the two pairs. Okay, so for coordinate covalent bonding, only one element is sharing electrons. So we have a lone pair of electrons, okay, and then we have one element carries the lone pair. The lone pair is the unshared pair, and then the other element carries the valence electron. So it exists between the lone pair, the element carrying the lone pair, and the one carrying the valence electron. So like I said, the difference between covalent and coordinate covalent is that in coordinate covalent, only one atom is carrying or sharing what? The electron. So an example of this is the one you have between ammonia and water. Okay, so that is for coordinate covalent bonding. Now, for your metallic bonding is a type of bonding in which the positively charged nuclei of the metal ion is attracted to a sea of mobile electrons. So the positively charged nuclei of the metal atom is attracted to a sea of mobile electrons. Now, take note, your metals carry a positive charge. Okay, and the reason your metals carry a positive charge is because your metals are electron donors. So they lose electrons, and because they lose electrons, they become positively charged. Okay, and remember when I was talking about covalent and ionic bonding, I said ionic bonding is the type of bonding that exists between a metal and a non-metal. So you have the proton donor and the proton or the electron acceptor. So your metal ions or your metal atoms carry a positively charged nuclei. Okay, so metallic bond is the type of bonding that exists between a positively charged nuclei of a metal atom and a sea of mobile electrons. Okay, so that is for your metallic bonding. And there's no way we can talk about metallic bonding without discussing the properties of a metal. Why? Because it is metallic bonding that gives metals their characteristic properties. Okay, so what are some of these properties of metal? Number one, we know that metals are good conductors of heat and electricity. What does that mean? They allow heat and electricity to pass through them. Okay, we also have insulators, but insulators are, they don't allow electricity or heat to pass through them. Okay, but for now, we know that what metals are good conductors of heat and what electricity. And also another property is that we know that metals are malleable. Malleable means that metals can be bent into shape. Metals are also ductile, meaning that they can be drawn into wire. Also, metals are hard and they are shiny in appearance. Okay, so these are some of the properties of what a metal. So, like I said, it is the metallic bonds that give metals their characteristic and properties. So that is that about what our metallic bonding. So lastly, we want to talk about hydrogen bonding. And what is hydrogen bonding? Hydrogen bonding is a type of bonding that exists between hydrogen atom and an electronegative element. So it exists between hydrogen atom and an electronegative element. So what is an electronegative element? An electronegative element is an element that gains electrons. Okay, so they gain electrons. They are proton acceptors, they are electron acceptors. Okay, so because they are electron acceptors, they are highly reactive. An example of an electronegative element is fluorine. Now, fluorine is the most electronegative halogen. Your halogens belong to group 7, by the way. So, fluorine is the most electronegative element, meaning it is the most reactive element amongst the halogens. So, like I said, hydrogen bonding exists between hydrogen atom and an electronegative element. Another example of that is water. So water, which is a hydrogen, which contains hydrogen, is bonded to what? Oxygen. Oxygen is also an electronegative element. So please take note, electronegative elements are electron acceptors. Okay, they are electron acceptors and they are highly reactive. So these are some of the bonds that we have under chemical combinations. Please, if you have any questions, feel free to leave them in the comment section below. Also, if you have any contributions to this lesson, if you want to talk about something that pertains to this topic, please also leave it in the comment section below. With that, I remain your tutor, Benetidio Mamogo, and see you in the next class.